All right, so welcome to this stream on Manning's Twitch channel. Thanks so much for joining us. My name is Boris Paskiver, and I'm the author of Pandas in Action, which is set to be released sometime early next year, probably around April or maybe May. So over the course of the next hour, I'm going to be showing you basically working through a sample data set using Pandas. And the topic of the hour will be working with text data, so manipulating text in all kinds of formats, whether it be uppercasing it, lowercasing it, splitting it, removing characters, adding characters, anything that you will ever want to do with text. We're going to practice doing that with a sample data set. This is actually a data set and a combination of code samples that is copied directly from a chapter in the book. So if you like what you see, feel free to check out the book, Pandas in Action, through Manning's MEEP program, and you'll have access to basically all the code that I'm going to write today. All right, so if you're unfamiliar with Pandas, Pandas is a data analysis library built on top of the Python programming language. It was released publicly a little over a decade ago, I believe in 2009, and it's really exploded over the last couple of years in the field of data science and data analytics. So Python now has a huge ecosystem of data science tools that incorporate all kinds of complex disciplines, statistics, machine learning, natural language processing, etc. But no matter what domain or field you're working with, you're going to have to manipulate data or contort it in some way, shape, or form. And Pandas is sort of the ecosystem, the epicenter rather, of that ecosystem in the Python data science community. So it's a general all-purpose data analysis toolkit. So anything that you can do in a graphical spreadsheet application like Excel or Google Sheets, you can also do in Pandas. Of course, the advantage of using a programming language is you gain the benefits of things like automation. Programming languages are really good at repetition. You gain repeatability. You gain the advantages of being able to use your code across multiple files, repeat them. In a coding environment such as this one, which we're staring at right now on the screen, this is Jupyter Notebook, you also have the ability to walk through step by step the logic that you used to solve a problem. So unlike an Excel spreadsheet where you just get the final result, here you can actually see how an analyst reached their conclusion rather than just their final numbers. So whether it be telling the story of data or automating it, or even just exploring a new technical domain, growing your expertise, because it never hurts to learn to program because it can help you in so many different aspects of your life and your efficiency. Pandas is a really great jumping point. It's a really great tool to learn if you are an Excel analyst and you're looking to pick up the next cool thing, if you will. So what I want to do in this next hour, of course, is just walk you through a data set, show you how you can do some common text-based operations, and we'll take it from there. So we are in this environment called the Jupyter Notebook, and the first thing I need to do here is actually import my Pandas library. So you, of course, need to have this set up on your computer, including Pandas. We're not going to spend time on that tonight because it might take a while to set it up, but of course, all of that is covered in the book. And if you're not interested in the book, you can always check out the Pandas documentation as well for a complete installation guide. So I'll begin by importing my Pandas library, and usually it's assigned the alias PD. And at the top level of this library, you can think of it almost like the lobby of the library, kind of the entrance to it. We have a whole bunch of available functions for reading a file into our program. So there's a function here called read CSV. And again, if you're unfamiliar with the word function, it works the exact same way as it does in Excel. It's just a procedure. It's some kind of operation that we can tell the library to do for us. So in this case, I'm literally saying, Pandas, read this CSV for me. So in the exact same directory where I have this Jupyter Notebook, I have a sample CSV file that I'm going to use for this tutorial, and it is called Chicago Food Inspections.csv. And for now, I'm just going to execute the cell so we can preview what it looks like. This was copied, I believe, directly from the city of Chicago's government website. So it's a list of restaurants or food institutions throughout the city of Chicago. We have the name right here on the left, and we also have the risk that was assigned to it based on a food inspector's analysis. So obviously restaurants have all kinds of risk problems like rats or unclean utensils or anything like that. So this is the actual public data that's available. So if you're curious about finding out which restaurants or which chains have the most violations, things like that, you can find those kinds of stories in a data set like this. And immediately upon importing, we can see that there's already some kind of text issues here, right? So for example, these names in the left-hand column are all in uppercase, and some here we can see are all in lowercase. The risk column doesn't appear to be too bad, but it's kind of capturing a lot of different information. For example, you might just be interested in getting the number of the risk, like 1 or 2 or 3. So a question might be, how do we extract just that numeric component from this column, things like that. So all of these kinds of questions we'll be talking about very shortly. So what we're seeing here to the human eye, of course, is basically a table. It's a combination of rows and columns, much like you'd work with in Excel. But in Pandas, this type of data structure is called a data frame. Pretty simple. A data frame is just the equivalent of a table. It's a combination of rows and columns. The column is the observation, or sorry, the variable. The column name is the description of what is being stored in that column. And then each row represents one record, right? So the name for the first restaurant is the Marriott Marquis Chicago, and the value for the risk column is risk 1. And the same logic applies for all the records in the data frame. At the bottom here, you can see we have 153,000 rows and 2 columns in this data frame. So what I'm going to do is save this to a variable. I'm going to save it to a variable called inspections. And basically that just allows me to reuse the data frame later in this notebook. And I'm going to use a method here on a data frame called head. A method is just a function that we can call or invoke upon a data frame. And what the head method does is just show us the first 5 rows. So rather than outputting the entire data frame, I'm just going to take a look at the first 5 rows, just so I have a point of reference as we proceed. All right, so let's first focus on the name column on the left. Let's take a look at some of the manipulations we can do on it. So the first thing I'm going to do is to actually just extract that column, target it. So I'm going to do inspections, which is my data frame, and I can access a single column through square brackets. And in here, I can provide a string with the column name that I want to access. In this case, the name of my column is actually name. So I'm going to write that out. And this is going to return to me another type of object in Pandas called a series. A series is a one-dimensional labeled array. The simplest way I can describe it is as a single column, while a data frame is a two-dimensional data structure, meaning there's more than one point of reference that is needed to extract any given value. So for example, if I was targeting Jet's Pizza, I would need to know both the row and the column number in order to get to this value. Because I need 2 points of reference, it is a two-dimensional data frame, or two-dimensional data structure. In comparison, the series, which we see right here, is a one-dimensional data structure because you only need 1 point of reference to extract any value from it. So for example, if I wanted to get to the value room 1520, I only need 1 point of reference, which is this number to the left here. If you're curious, by the way, about these numbers on the left, this is what's called the index, and essentially it's just assigning each row a place in line starting from 0. So the very first row is assigned position 0, the next one is assigned position 1, so on and so forth to the end. And so each row is assigned kind of its own unique identifier by which we can access it. So the index doesn't have to be numeric. This is just a default that Pandas relies upon because we haven't given it any kind of identifiers by which we should use to locate or find each row. So it just says, since you're not going to give me a custom set of identifiers, I'm just going to assume that you want these rows ordered sequentially, and I'm going to start that count at 0 and give you that information here on the left. All right. So it may not be super apparent right now, but there's additional problems that are starting to emerge from this column of data or from this series that we weren't quite seeing when we were looking at it right here in the big picture. So notice we also have white space. If I highlight right here with my mouse, you can see there's additional white space characters to the right of Chicago. And the same rules apply, by the way. We can't see it to the beginning of text as well as to many other rows in the series. So we have white space at the beginning and white space at the end. So let's first talk about how we can remove that. So on any series object like this one, we have an attribute. An attribute is almost like a property. It's just something you can access on the given data structure. It's a characteristic or detail that may sometimes expose other nested objects or data structures that we can deal with. So the syntax is going to be .str. And if I just output this result, you can see it's a nested object on our series called string methods. And it's on this object that we can call all kinds of methods that will manipulate the series. All right, we'll take a look at how to do that in just a moment. For now, I want to do a quick review of some of these string manipulation operations in just vanilla Python. So for example, if I have a sample word, I'm just going to create a word variable here and assign it to a word like cheesecake. And what I'm also going to do is add some white space at the beginning and the end of this word, just so we have something to work with. Here's our word. There are a bunch of methods related to removing white space that we can utilize. First up, we have the rstrip method on a string in Python. That is short for right strip, and it strips or removes white space from the right side of the string. So if we take a look at this output and we compare it to the one above, here you can see in my original word string, there is white space to the right of cheesecake. Here it's removed. If I want to do the same thing to the left side, there is a complementary strip method called lstrip. Makes sense, right? L for left, left strip. That removes the white space on the left side of the string. So if you compare it right here and this output right here, you can see the left-hand white space has been removed. If you want to target both sides simultaneously, there is a method called strip by itself. No L or R, just strip by itself. So you can see right now, we're going to get cheesecake and all of the white space has been removed. So if we want to use any of these string methods, they're all going to be available, but instead of calling them on a single string like we're doing right here, we obviously need to call them on every single value within our Pandas series object. So we want to tell Pandas, take this string, Marriott Marquis Chicago, call strip on that, then do the same thing for Jets Pizza, then do the same thing for room 1520, all the way through the 150,000 rows in this data frame or series. So on this str object, you simply invoke another method, and it's going to be the same familiar Python methods that we see above. So for example, if I want to remove the white space at the beginning of each string or the left side, I can call lstrip on this nested str object on the series, and we're going to get a brand new series with all of the white space from the beginning removed. I may be able to highlight it, but I assure you it's going to be removed. Same rules apply if I want to remove it from the right side. Instead of invoking the lstrip method, I can simply invoke the rstrip method. You can see right here the white space is removed. And probably what I want in this scenario, of course, is to remove all of them from both sides. So I can call the general strip method, and that's going to give me the series that I want with all of the white space from both sides, beginning and end, removed. So what this is going to give me is a brand new series, meaning my original one in my data frame has not been affected. I still have the data as it came in from the CSV. So if I want to make this operation permanent, I simply need to reassign this new series to my original series. So what I'm going to do is use an equal sign here. In programming, the right side is evaluated first. So I'm going to grab the new series generated on the right-hand side with all the white space removed, and I'm going to reassign it back to its original slot, the name column in my inspections data frame. And if I take a look at my inspections data frame afterwards, all of the white space has been removed. In fact, I can even combine traditional Python iteration protocols with what I did above to ensure that every single column has its white space removed. So what I can do, for example, is get a list of all of my data frames columns. So here we have the columns of name and risk. It's available as this columns attribute on my inspections data frame object. And what I can do is use something like a traditional Python for loop. So for each column in this list that I see above, I want to basically perform this logic right here. I'm going to copy it and put it here. But of course, rather than writing to my name column, I want to write to whatever column it is that I happen to be dynamically iterating over in the current iteration, which is going to be represented by my column for variable right here. And if I replace it on both sides of the equal sign and run this, now I'm going to ensure that every column in my data frame has had its white space removed. Okay, so next up, let's take a look at casing. It's going to be pretty much the same thing we've been doing earlier. We're going to be accessing the str attribute on our Pandas series, and we're going to be calling some kind of method on it to manipulate the values within that series. So first up, let's talk about lowering, meaning lowercasing all of our data. So once again, I'm going to target my name column. And let's say I want to lowercase all of the characters across all of these strings. So once again, .str, the Python method that you traditionally call on a string is called lower. It's the exact same logic here, except we're using it on the str attribute, or more specifically, the object that that attribute exposes. So right here, we're going to get a series object with all of the strings in lowercase format. There is a complementary upper method, which is going to uppercase the letters. I believe towards the end of our series, if I take a look at the end of it with the tail method, you can see we have a couple that are in all lowercase, or at least have some letters in lowercase. So I'm just going to call the upper method right here on this small series of 5 values, just so you can see the result. You are, of course, welcome to call it on the entire series as a whole. But right here, .str.upper, and you can see all of the letters are going to be in all uppercase. So this is all uppercase right here, and this is, of course, all lowercase. All right, there's a couple other complementary ones that can prove pretty helpful, especially if we take a look at what we're doing here. So here's my original column again, nothing has changed. What I think would be best here, of course, is to capitalize the first letter of every word, right? That's the way I would traditionally expect to see a restaurant name listed. So Python does have a capitalize method, but it actually capitalizes only the first letter of every string. So this one will give us one result, but it's not necessarily what we want. You can see the M in Marriott right here is capitalized, but the M in Marquee and the C in Chicago are not. So if you actually want to capitalize the first letter of every word, and every word, of course, is separated by a space, there is an automatic method available called title, which does just that. What title is going to do is capitalize the first letter of each word. Now, it's not perfect. For example, when it looks at Jet's Pizza, it thinks that the the apostrophe after the T is indicative of a separation, and thus it thinks the S right here should be capitalized. So it's not perfect, but you can see for most of the results, it does exactly what we wanted it to do, which is to capitalize the first letter of every subsequent word. We can also see it does the same thing with the slash, which gives us a capital B in Baskin-Robbins when it was originally a lowercase b. So we can see it does a pretty good job with slashes, with apostrophes, with spaces, but it isn't perfect. All right, so those are some quick manipulations as far as casing goes. We saw upper, lower, capitalize, title, and we also explored the strip family of methods, which removes white space. All right, next up, let's talk a little bit about string slicing. So let's take a look at my inspections data frame again. Here is a preview of the first 5 rows. And this time around, I want to target my other column, which is the risk column. So I'll extract it again with square brackets, take a look at the first 5 rows, and here's what it looks like. So ultimately, where I want to get to is extracting, let's say, the number, or maybe the risk level, like high, medium, low, from this string. And there's many different ways to do it. If you're familiar with regular expressions, that's a specific field of programming where you use basically symbols to indicate certain characters. So for example, you can tell Python to look for a combination of any 3 digits in a row, followed by a comma, followed by the letter R, right? And you can get pretty advanced with the algorithms that you use to search. You can say at least this number of characters, or this exact number of digits, or exactly 2 or more occurrences of the letter Z. You can get pretty granular. But for now, I'm just going to use very simple techniques, the kind you might use in Excel. We're going to dive a little bit into regular expressions towards the end of this hour, but I just want to show you how you might solve it if you weren't familiar with those more advanced programming concepts. So first up, let's take a look at how many total rows we have in our data frame again. We can pass our data frame into Python's built-in len function. We can see we have 153,000 rows. Well, what if I want to first find out how many counts there are of each risk in the risk column? In other words, I want to know how many risk 1s there are and how many risks 3 there are and risk 2s, and maybe there's others that I'm missing. One really easy way to do that is to take my column and call a method on it called value counts. What value counts is going to do is give me that number of counts for each unique value. So it turns out there's 4 unique values in my risk column: risk 1, risk 2, risk 3, and a special one called all, which means the restaurant actually had all of the risks mentioned above. So those are the worst violators imaginable. There's actually another hidden value that's not present here, but I can show it to you by applying a specific parameter, or in other words, an argument or input to this method called drop NA. I wouldn't worry too much about this now as far as the syntax, but you're going to see an additional value appear here called NaN. And NaN is Pandas' internal designation for a missing value, or in other words, an absent value, something that is not present. So what this means is in our 153,000 rows, there's going to be 66 rows where there actually isn't a value in the risk column. So in the original CSV, there was just simply nothing there for that row. And Pandas needed to place something so that it can construct our data frame for us. So it places this NaN placeholder to represent the idea of nothingness or nullness or the absence of value. So before we proceed, I want to make sure we get rid of that, because if we don't know the risk, then we really can't do anything with that column, right? Let's say for the purposes of our business logic, we're going to remove it entirely. And then, just to make it easier to extract a number from each of these values, for example, I want to get the number 1, the number 2, the number 3, I'm going to also change the all right here to be risk 4. So I'm creating some kind of consistency in how each one of my strings begins, so that makes it a lot easier to extract the number that exists within each string. Okay. So the first thing I'm going to do, as I mentioned, is I'm going to remove the NaN values from my risk column. So on my data frame, I have a method called drop NA that drops the NaN, or the absent values. It accepts a parameter called subset, which specifies the columns in which I want to look, and I'm going to look within the risk column. And if I preview this, we're not going to necessarily see the results, but rest assured what Pandas has done is removed all the rows from my data frame where the risk column had a missing value. So this gives me a brand new data frame. My original one is not overwritten yet. So what I want to do is provide a special parameter that is going to make this operation permanent. And that is a parameter called inPlace equals true. Again, I'm kind of skipping over some of these additional parameters that are not specifically related to text parsing and working with text data, just because it would make this stream go a lot longer than just an hour. But all of these topics are covered in greater detail throughout the book. So I've taken care of removing my null values or my missing values. The next thing I want to do is to replace the occurrences of this all string with a risk 4. So what I'm going to do is call a method on my data frame called replace. There's a parameter here called to replace that represents what I'm looking for. I'm looking for the string all, and right now I'm going to be looking for it only in my, across the entire data frame rather than only in the risk column, but I think that's okay for now, just for the purposes of this example. So what do I want to replace my value of all with? I want to replace it with a new value of risk 4. And just to keep it consistent with our other ones, where there's a space and a parentheses and a classification, I'm going to call this classification extreme. And once again, this is going to give me a brand new data frame. We don't see any risks for right here, but that's to be expected because there's only 19 of them in our 153,000 row data frame. But somewhere in here where they do occur, I have replaced them. So this is basically the equivalent of an Excel find and replace operation. So I want to make this operation permanent. So just like in the method call above, I'm going to add a parameter called inPlace equals true, and that's just going to ensure that we make that operation permanent. So now if I copy this code from above and re-execute it, we can see our all value has been replaced with risk 4 and all of our null values have been removed. All right, so now let's talk a little bit about slicing, or in other words, extracting the right risk number from each one of these values in our column. So this is very similar to something like a left function in Excel, or a right, or a mid. We can basically start extracting from the beginning of a string, from the end of a string, from the middle of a string, whichever way you want to tackle it. So in Python, string character counts start at 0, which means in each of these strings, the letter R occupies position 0, the I occupies position 1, the S is 2, the K is 3, the space is 4, and the number itself is 5. So we want to start at index position 5 when we start our extraction. So what I'm going to do here is once again target my risk column. Here's a reminder of what it looks like. And we're once again going to target my str attribute. And on this object, I have a method called slice. So slice accepts 2 arguments. There's actually a variety of different syntaxes to do this. But if you prefer the argument approach, the first argument is where we're starting from. In this case, we're starting from index position 5. And the second argument is where we're ending. And that is exclusive, which means we're going to go up to that position, but not actually include it. So I'm just going to put the value 6 here. So what this means is start at 5, start at the character that's index position 5, which is actually the 6th character, then go up to index position 6, but don't include it. So this is equivalent to saying, just get me the character at index position 5. And if I do this, you're going to see we've extracted the number from each one of our risks. So right here, you can see if I output this series above, or at least the first 5 rows, we can see risk 1, 2, 3, 1, 1. And right here, we have 1, 2, 3, 1, 1. And the alternate syntax for this is using Python's list slicing syntax. If you're familiar with that, it looks like this, 5:6. And that's going to give me the exact same result. Let's see, it's not working here. Let's see what else I did wrong here. Maybe they've removed that syntax since. All right, I guess I was a little mistaken here. So in that case, we'll stick with just the method that we have right here. All right, let's see what else we can do. We can also provide negative values here if we want to move to a position relative to its end of a string. So let me give you an example, just with a basic Python string. If I have a string like programmer, and I want to slice from 3 to -1, that's going to pull from index position 3, which is 0, 1, 2, 3. That's going to pull from the G all the way up to index position -1, which is the last character in my string. In that case, it's going to be the R. But remember, the second argument is going to be exclusive, which means we're going to go up to it, but not actually include it. So this is going to go inclusively from G all the way to the E before the last character, which is the R. So we're going to get gram, like so. All right, and we can apply this to something like our risk column. So once again, if we take a look at what it looks like, let's say I don't want the number, but I want the actual classification, like high or medium or low. This problem is a little bit trickier, right? Because the length of each classification is different. It's 4 characters in high, it's 6 in medium, it's 3 in low. So it's a little harder to specify one number that fits all of them. But if we use the syntax from above, it actually is not super difficult. So what I can do is, once again, take my risk column, call the slice method. I'm going to start at index position 8, which is actually the first character after my parentheses. So it's going to be the H here in high or the M in medium. That is consistent no matter which one we have, because it's always going to be risk followed by a space, a number, a space in the parentheses, and then my word. So each word or each classification is always going to start at position 8, but it's the length of it that is different here. And what I want to say is go from there up until the very last character in the string, which for all of them is going to be a parentheses. And once again, the last character is not going to be included. So this means go up to it, but not actually include it in the final string. So no matter whether we're dealing with the word high or medium or low, they're all going to start at position 8 or index position 8 in the respective strings, we're going to pull from that character all the way up until, but not including, the last character in the string, and that's going to allow us to pull out just the classification by itself. All right, so that is a little bit about slicing. There's obviously a lot of different syntactical options here when you want to pull out from left, from right, from the middle, include, exclude, etc. But hopefully this has given you a big picture overview of just what is possible with pandas. There are, of course, more examples in the book. Next up, let's move on to Boolean methods. So a Boolean, of course, is a value that is either true or false, and it's used to express some condition of truthiness. There's just some relationships that are either or, right? Like on or off, enabled or disabled, true or false. It's just one or the other, like a switch. So for example, if I were to use something like Python's built-in operator, that checks for the inclusion of a substring in another string. So for example, if I want to see if the word pizza is found in a string like Jet's Pizza, the answer is true. Right? It's not a number, it's not a string, it's a statement of fact. It's either true or false that pizza is in Jet's Pizza. And if I search, for example, is the string tuna found in Jet's Pizza, that of course is going to give us false. And that's all their Boolean is, either true or false, yes or no. So we can use some methods on our string or .str object to return series of Booleans for us, and we can then use those Boolean series to filter our data frame. So for example, what if I wanted to take my list of restaurants in Chicago and I wanted to find the ones whose name includes the word pizza? I don't care whether pizza is at the very beginning or at the very end or in the middle, just any restaurant that has the word pizza in the title. All right, so this requires us to combine a couple different ideas. First up, this search is always case sensitive. So we can't simply search for something like pizza because our pizza can be spelled like this, or it can be spelled like this, or it can be spelled like this. Who knows how this data is stored? So the first thing we need to do is to normalize the data, which basically means make it consistent, right? We need to make everything either consistently all lowercase or consistently all uppercase so that we can search for only one variant of the string pizza with a special, casing of characters. So what I propose we do here is first use my lower method to give me a series with all the characters in lowercase. And now that there's that consistency, in here I can invoke a different method to search for the presence of a substring. And this one is called contains. Now it's important that whenever you're combining multiple string methods together, you can't just simply call the next one like so. Because what this lower method is actually returning to us is a brand new series. And on any series, as we see right here at the beginning, we first have to access its str attribute to get access to this nested object, which does the actual string manipulation. So the first thing I need to do here is to once again access .str on this brand new return series. And on that object, I want to invoke a method called contains. Contains checks for the presence of a value or a substring in every one of the series values. What do I want to search for? The string of pizza. So I'm going to get a Boolean series, right? So we haven't extracted these rows yet, but we have a series where a false indicates that that row does not have pizza in its name, and a true indicates that it does. So just as a reminder of what we're dealing with here, here are the first 5 rows of the name column. You can see the second row, index 1, is called Jet's Pizza. So right here, we're getting a true for that. All right. So in order to filter in Pandas, I need to keep this series of Booleans. I need to preserve it. So I'm going to save it to a variable called hasPizza. So hasPizza is a Boolean series. It's a series of Booleans where a true indicates that a row has pizza in its title. What I want to do is extract just the rows that have a value of true in this column. Of the 153,000 rows, give me the ones for which the index position here has a value of true. The way we do that is we simply put my data frame, and then we provide it the Boolean series, hasPizza. And what Pandas is going to do is use the common index positions to identify which rows could be kept. So in has pizza, if row 1 right here has a value of true, then it's going to keep row number 1 from inspections. And so now what we're going to get is all of the companies that have the word pizza somewhere in their name. You can see right here, Jet's Pizza is at the very end. Right here, Neri's Grill and Pizza. Pizza's at the very beginning. Maybe somewhere else, pizza's at the very middle. All cases are covered here. All right. Now, if you're searching for something different, for example, not just the inclusion of a substring, but its specific presence at the beginning or the end of a string, there are also complementary methods for that. So for example, let's find all of the restaurants here that start with the word tacos. So what I'm going to do here is follow the exact same protocol. I'm going to start by getting my name series. I'm going to lower every value in this series. So now they're all in lowercase. And here I'm going to once again access .str. And this method is called starts with. So while contains is going to search for the presence of a substring anywhere, starts with is going to search for it only at the beginning of a string. So right here, I'm going to search for the word tacos at the very beginning of a value. So when I get this Boolean series, I get a bunch of falses for the first 5 rows and the last 5 rows. That's totally fine because we have 150,000 more in between and there are some trues in there. So as always, I'm going to save this to a variable. I'm going to call it starts with tacos. And once again below, I provide my data frame, a pair of square brackets, and my Boolean series. And now we're going to get just the restaurants that start with the word tacos. All right, same rules apply if I want to get it from the end. So right here, inspections name is my column. Let's lowercase all of the characters. And let's look for the ones that end with the word tacos. So we explored the method contains earlier, the starts with method a moment ago. This new method is called ends with. It returns a Boolean true if your series value ends with the argument you pass in here, in this case, tacos. So I'm going to save this Boolean series to a variable called ends with tacos. I'm once again going to provide my data frame, square brackets, ends with tacos. And now we're going to get only the restaurants in this list that have a value in the name column that ends with tacos, right? So tacos must be at the very end of the string. Okay, so finally, let's end the stream with a discussion on splitting strings. This is another common thing you may want to do in a graphical spreadsheet software application like Excel. So for this one, I have a brand new data set, and it is found in a CSV file called customers.csv. So I'm just going to import it right here. It's pretty simple. Once again, we have 2 columns. We have the name of a customer, and we have their address, right? And many times we're going to have situations like this where there are actually multiple pieces of data hiding within one column. So for example, maybe we want not the full name of a person, but rather their first name and their last name in individual columns. Or for an address, maybe we want the street and the city and let's say the state and zip code in separate columns as well. So we need to split a value based on the presence of some kind of character or delimiter. For example, in a name, that character may be the space. The space is what splits up the first name and the last name. Or in an address, it may be the presence of a comma that splits it, right? And we need to identify what that is, and then we can communicate that to Pandas, and Pandas will split it accordingly. So let's begin by assigning this to a variable. So I'm going to assign it to one called customers. Once again, it is a 2-column Pandas data frame. And let me remind you first up how this works in a plain Python example. So if I have a variable called phone number, and I assign it to a fake phone number like 555-123-4567. As I mentioned, I can split a string based on the presence of a given character. So if I wanted to split this into 3 sections separated by the hyphens or the dashes, I can call a method on a string called split. and I provided an argument of the character that I want to split by. So in this case, of course, it's going to be the hyphen. And what Python is going to give me back is actually going to be a list, which is a different type of data structure. It's one that stores multiple elements in sequential order. And here you can see it has found all of the occurrences of the hyphen. It's removed the hyphen entirely, and it's basically split up the original string into a list of 3 separate strings based on where that identifier or that delimiter occurred. And we're going to do the exact same thing here with Pandas, but we're going to apply it to an entire column. So, as always, we begin by targeting a specific column. In this case, I'll target my name column. And let's say I want to split this by the presence of a space. So once again, we know all of our string operations are found on .str. So on this one, I'm going to pass in or invoke the split method. I have to pass this method the argument of what I want to split by. This time around, it's going to be a single space. And what I'm going to get actually is going to be a series of Python lists. So a series can actually store a wide variety of data types. It can store obviously integers, floating point values, strings, Booleans. Well, it turns out it can also store Python lists. Now there are some problems here, which is that some of our names have things like the 3 right here at the end, or maybe they have a junior or a senior. So the problem is that some of these lists are 2 elements long, while some of them may be 3 or more. So maybe what I want to do here is limit the total number of splits that I'm going to do. I may say, for example, split it at a space, but only do it once. Don't do it any times more than that, right? Because I don't want to end up with something like Michael and then Vincent and 3. I really just want to end up with Michael as my first value and Vincent 3 as my second one. And that kind of consistency across the lengths of all of these nested lists makes it a lot easier to do operations with them. Whenever you're working with data types that are consistent in that manner, it's usually less likely that you're going to run into a bug. So there's a parameter I can provide here called n. N is just short for number, and it specifies the max number of splits. So if I want to just do 1 split, you'll notice in this scenario, we're going to limit it to just 1 split at the first space. So Frank and Manning is going to be the exact same as before. Same thing goes for Elizabeth Johnson. However, when we get to a value like Michael Vincent III, we're going to only split it once, and you could see the first value in the list is Michael, and the second value is Vincent III. And it doesn't matter if there are 4 spaces throughout that string. The Pandas library is only going to split it the first time it sees a space. All right. So now, how do I get a given value out of these lists, right? What if I only want each person's first name because I want to, for example, assign it to a new column or a new series? Well, for that, there is a method called get. I'm once again going to invoke it on the resulting series that I get back from my split method. And get is actually going to take the index position that it should extract from each list. So my first name is the very first element in each one of these nested lists. And the first element in Python in a list always has index position 0. So here I'm going to get index position 0 from each list that we get back from my split method. So now we're going to get the first name of each person, which is the first element from each nested list. If I want the last name, I can of course provide number 1 here. That'll work. Or alternatively, this is a similar idea to the one we saw earlier with slicing. I can actually provide a value of -1, and that's going to proceed relative to the end of the list. So -1 means get me the very last element from each list. It doesn't matter whether the list has 2 elements or 3 or 5. In this case, we've ensured a consistent number of 2, but this syntax will get me the exact same result. It's going to get me the last element in each nested list, which is equivalent to getting the last name or the element at index position 1. So there are many times multiple syntactical options for accomplishing the same result. All right, let me go back to the original thing we saw right here, which is a series of Python lists. There's an additional parameter that I can provide to my split method called expand, and this one actually expects a Boolean value, so I'm going to provide a value of true. And what it's going to do is expand the list into a Pandas data frame. So right here, rather than storing it in a Python list, I'm going to create a brand new data frame with two new columns, one storing the first element, the one before the first space, because we're still limiting to only one split. And the second column is going to store the substring occurring after the encounter of the first space. So basically the exact same thing we saw earlier with the list, it's just now expanded to be a data frame. And obviously because Pandas does not know what column names we want to grant in this data frame, it just defaults to numbering them numerically the exact same way it does the rows right here. There are of course ways that we can very easily overwrite existing columns if we want. In fact, let's see if we can try this. So what I'm going to do here is this. I'm going to move this a bit to the right. I'm going to say that in my customer's original data frame, I want to add not just one column, but two. So I'm going to provide square brackets and a list of the values first name and last name. And that's designating two columns that I'm going to add. And the two columns that I want to add are going to be equal to the two columns that I have generated right here. So if I execute that and it works, you can see we've now extracted the contents of the name column into two separate columns, first name and last name. If we want to go ahead and remove that name column, that's totally possible. We can use Python's built-in del keyword or delete. There's also a method you can call in Pandas as well. As always, multiple ways to solve the same problem. But for now, I'm going to delete customers targeting the name column. And if I take a look at customers, you can see that we have removed the name column entirely. All right, same rules apply for any other split. So for example, here's one more example. If I want to target my address column and I want to split all of these strings based on the presence of a comma, once again, .str.split, providing the string that I want to look for, or in other words, the identifier by which Pandas is going to split a string. So in this case, I can provide a comma, which is a good starting point, but you'll notice actually that it's going to include the space after each comma as well. So a slightly more clever trick here is to actually split by a substring of two characters, which is a comma and a space. Every time Pandas sees a comma and then a space, that's what it's going to use as its splitting point. And that's just going to ensure that we don't have any extra white space lingering around at the beginning or end of our split strings. So here we go. We've split it based on the presence of a comma. We can provide something like the expand parameter with a value of true. And here we have a brand new data frame. You can see we've split it by street name, city, state, and zip code. It really was as easy as that. And then of course we can choose which columns we want to keep, choose which ones we want to remove, etc. All of that is possible with Pandas. That's really all I wanted to show you in tonight's stream. I know it was a quick whirlwind tour of running through all of these different functionalities that we can do with text in Pandas, whether it be changing the casing, lower casing, upper casing, fixing capital letters, removing white space, replacing characters, splitting. There's all kinds of functionalities, and we've only really scratched the surface. So hopefully it wasn't too crazy or too hectic. I know for people who are brand new to this, there's a lot of syntax to explore. You're also simultaneously learning a programming language, in this case Python, sort of simultaneously, so it can be a difficult journey. But I hope at a bare minimum that it's given you a sense of what is possible. And that's the most important thing here, that you have a sense of what you can do with Pandas. The syntax and the understanding and the configuration will come with practice and with time. All right, trust me on that. So with that, I do want to again remind you, if you're curious about learning more about what Pandas can do for you, you can pick up Pandas in Action. It's available on Manning's MEEP program, which is its early release program. You can then get the book in its early format, provide feedback and helpful commentary to help improve it before its publication, and then you can also pick up the actual book when it comes out. You'll get the final copy when it is actually published. All right. If you're interested in more of a visual learning style, I also have a 19-hour Pandas course available on udemy.com. It's a lot slower, a lot more slowed down with a lot more examples. We have a lot more time in 20 or 19 hours to cover more material than we do right here in the hourly stream. But irrespective of which one you choose, or if you choose both, I think they're both helpful resources if you're picking up this powerful data analysis toolkit that continues to grow in popularity and reach with every passing month. So hopefully this has been helpful and beneficial for you, and best of luck in all of your coding endeavors. See you soon.